Okay, so I've downloaded the spreadsheet I showed in the previous video, and so it's type 1 demo method 3, and I've gone to the tab that says fake correlation, and what we can do is let's make these percentages a bit nicer, and let's think about something that would be good examples here. So these are participants and these are variables. Let's say that this variable is happiness and this one is income, let's say that. So this is percent of the top how many of your top possible income, and this is how happy you feel. Here we have how many participants in each group we have, and so this shows the p-value. In this case, we're getting a p-value of 0.29, 0.3 about, and this is how many percent is this correlation of about 0.4. So how many? So we can see that 15% is the percent that's explained, that these variables explain. And we have 30 participants, so we have 30 rows here. And each of these is actually a random number. So here we have two variables of random numbers, and we have a p-value lower than 0.0. So now when I press F9 to recalculate this sheet, I'm getting new random numbers. And the p-value is no longer statistically significant. But I can keep on pressing. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. And on the 9th reshuffling, I got the p-value that is so two variables that are just random numbers, and I get a statistically significant correlation. So in this case, it's a negative correlation. So you would go and, hey, actually, the more happy you are, the less income you get. And you would want to publish this, but not the previous 9 studies where you didn't get this result. We can also increase the sample size. So let's say we have 1,000 participants, and let's press refresh again, random numbers, and we can see that the p-value is always less than 0.05. It's just random numbers, so we can put this down to 300. Let's see how it works. And let's see, 1, 2. Now we got the positive significant p. Yeah, we're all still getting almost always a significant p-value. Say 100. 1, 2, 3, 4, 5, 6. On the 6th there was the yes. 7, 8, 9, and again there was a yes. So you can see that if there is a situation where you only whenever you have a statistically significant p-value, if you can publish those things, and you can't publish those things that don't show this effect, then you end up with a literature that only shows positive effects, and this is very important because p-value is one of the leading causes of getting published. So it's very hard to in normal settings to publish something where you have a p-value that's over 0.05. As we spoke about the discussion on extrasensory perception, the journals still often think that it's not their job to publish these findings where nothing is found. But we can, of course, when we're applying research and when we want to do something with it, it's very, very, very important that we know how many trials did you get to run before ending up with a statistically significant result.